We're going to continue our work on partial fraction decomposition, but now we're going to look at the process if one or more of our factors is quadratic, as opposed to both of them being linear. So remember, our original mission was to break the big fraction up into a couple of pieces. What were the original fractions that were added together to get the result that we're starting with? And so we're after finding the numerators of the original fractions. So if we have a fraction that looks like this, we have an x cubed and an x squared and an x, we know that we're going to have more than two linear factors because of that x cubed. So we've got to see if that denominator is going to factor for us. If it doesn't factor, there's no way for us to decompose this fraction. So the denominator has 4 terms, and we can factor it by grouping. There are 2 factors, x plus 3 times x squared plus 4. And here is our quadratic factor. And that's going to change what we're going to have to do in that numerator. It's not going to be enough just to put a over one factor and b over the other factor, because this factor could indeed have an x in its numerator where this linear factor wouldn't have. So when we set this up, we're not going to set up a and b. Over the quadratic factor, we're going to have to use ax plus b in the numerator, because the original numerator, which is what we're after, could have had an x term in it, and it could have had a constant term in it. Now, if it turns out that it didn't have an x term in it, we'll find out here that a is 0. If we find out that it didn't have an x term along with a constant term, let's say there was no constant term and only an x term, then we'll find that b equals 0. So we're not forcing something to happen that wouldn't have been there. So we still set it up originally like we did, but again we're going to use ax plus b as one numerator, and then we go along and we use capital C for the constant over the linear factor. The process from this point on is identical. We're going to cross multiply. We're not cross multiply. We're going to multiply both sides by the common denominator and come out with one equation. Here we have 3 variables instead of 2. So we multiply both sides by that common denominator. Over here, again, that's just going to leave us with the numerator. On this side, we're going to get ax plus b over x squared plus 4 is multiplied by x squared plus 4 times x plus 3, and the quadratic factors will then cancel, and we'll have ax plus b times x plus 3. So we're going to have to use that rainbow method or that FOIL method, first times first, outside, inside, and then last, and we come out with this result. And then we'll take this term, multiply it by the common denominator, and we're going to get c times the quantity x squared plus 4. So we'll get this term. Then this is the case where we are going to have to put like terms together. We have an x squared term here and an x squared term here. So the coefficient to the x squared term is going to have to be a plus c. Here we have an x term, here we have an x term, so the coefficient to the x term is going to have to be 3a plus b, and then our constant comes from 3b plus 4c. So we are going to have to set it up this way, and now we are going to have 3 equations here that we're going to have to solve for. Now, the result of a plus c has to be -1 because that's the coefficient of the x squared term over here. The result of 3a plus b has to be +11, and the result of 3b plus 4c has to be -10. So here's the system of equations that we come up with from this partial fraction decomposition. And so we can use elimination, we can use substitution, however you want to do it. We need to solve for a, b, and c. So what we're going to do is we're going to take this first equation and we're going to multiply both sides of it by -3. Then we'll take the second equation and we will add them together, because if we multiply this by -3, that's going to eliminate a for us. So 3 plus 11 is 14, -3a plus 3a is 0, and we have 0 plus b is b, and 3c plus 0 is negative 3c. So we eliminated a from this equation. Now we're going to take this equation and multiply both sides by negative 3 and add it to this equation, because there you can see that we will eliminate b. So we have several steps here to eliminate and find and solve for our variables. But here with this system, with these two equations, we eliminate b, and that just leaves us with c. And we find out that c equals negative 4. Well, if we know what c equals, we can use this equation to solve for a, and then we can use either of the equations to solve for b. So we find out that c is negative 4, a is 3, and b is 2. And we do that by back substitution. So if a is 3 and b is 2 and c is negative 4, we substitute those in there, and that finishes our partial fraction decomposition where one of the factors was a quadratic factor. And so this fraction was found, or is the result of the addition of these two fractions. So pretty much just like we did with linear factors, except the only addition, the only change here is that we have to have this new numerator on our quadratic factor, and that does force us to use the systems of equations to solve for our variables a, b, and c. So that's it. Come to class next time and we'll do some more partial fraction decomposition practice.